In this project, we're taking an Automation Direct CLICK Analog PLC, 2 analog input channels. We're using one of those channels to monitor the temperature of a thermocouple. This is a temperature transmitter taking the thermocouple signal and outputting 4 to 20 milliamps. That milliamp signal comes over to this circuit board here, which takes that 4 to 20 milliamp signal and turns into a 0.6 to 3 volt drop, which is then measured by the PLC. We're going to configure the analog input channel of the PLC so it properly measures in the temperature range we want. Our desired temperature range is 0 to 500 degrees Fahrenheit. So we want to scale the input here so that 0.6 to 3 volts registers as 0 to 500. So here we go over here. So Josh, go ahead and click on Setup. Let's go to CPU Built-in I/O Setup. And here we want to go to the Input tab. And down here we see the setup for AD1, that's channel 1, AD2. We want 0 to 5 volts. And then we want our input range 0.6 to 3, which it already is. Then over here, instead of 0 to 100, what do you think we're going to want?
500 there.
500. That way, it's going to read out in units of degrees Fahrenheit. And I want that to go into data register DF1. Cool. So click OK. All right then, let's go back to data view. Go to monitor, data view, the one that we called Aaron. Yeah.
Oh, not too fast.
No, you're there. And DF1. Oh, here's what happened. We didn't save to the PLC. So go ahead and close that. We need to do a right here,
This one?
right to the PLC, because that change we made on the scaling isn't actually in the PLC yet.
Will be now.
Will be now. There we go. Click OK. And as we do that, we're going to see communication lights on the programming port of the PLC right here.
Save it as Aaron.
Yeah, just save it under a different file name. There we go. I see lots of blinking lights there. Cool. As it's actually writing the program to the PLC. Then after this, we ought to be able to go back to the data view and see as we step our milliamps up and down, we should read out 0 to 500. Okay, it's downloaded. So back to data view.
Yeah.
There we go, 500. So 20 milliamps here reads as 499.75, so pretty close to 500. So as I step the milliamps down, I'm going to go to halfway, 12 milliamps. That should be how many degrees?
250.
250. We're reading 250.45. Cool. Then I go down here to 4 milliamps. That would be 0.
4 milliamps.
Exactly, 0%. It looks like we're consistently just a little bit high. I can actually take care of some of that problem through calibration. So let's step up here to 20 milliamps again. We're high here as well. Oh no, sorry, we're a bit low. 499. Okay, well maybe I'm happy where it's at. 16 milliamps should be 375, and it's 375.35. You know, to be within 1 degree in a thermocouple is doing pretty good anyway. So, and actually, come to think of it, this is a good application of critical thinking when it comes to calibration. We're reading a tad low on the high end. Now, based on the function of this thing, what is it we're hoping this thing will do?
Shut down if it gets too hot.
Shut down if it gets too hot, exactly. So the last thing I want to do is skew the calibration to make it read any lower. If anything, I want it to read a little bit high, that way it's erring on the side of safety. Does that make sense? Since we're already just a tad low here, and we're a tad high on the other data points, I'm going to leave it the way it is. But if anything, I'd be inclined to adjust this up a little bit, not down. But we're within 1/4 of 1 degree, and I have a 500 degree range with a thermocouple. That's better than the thermocouple will do itself, so I'm pretty happy. So now we can take that DF1 value in the PLC program and write some code that will cause it to activate or to turn this relay either on or off when we hit that point. And what I'm hoping to do is have that relay be something that's energized under typical conditions, so that when we shut down, we de-energize the coil, and that shuts our oven off. That way, the safest failure mode, if that coil burns out, oven shuts down.
Perfect.
Make sense?
Yep.
Cool, that's going to be our safety shutdown system on the oven.